You talked about the possibility of replacing the traditional protein using a single cell protein. And many people will begin to ask, how? How? And what beyond the how, the economics of the conversion.
Like you rightly observed, I'm emphatic about the fact that single cell proteins have a place of replacing our regular protein in our diets for many reasons. One, let's not look at a segmented population of people that are called themselves vegetarians. They strive on single cell proteins as their replacement for protein. One. Two, the reality is that it depends on the concept and the dimension of what you want to apply single cell proteins. One, in the whole feed industry, we are depending on either the plant proteins or animal protein. Either way, the single cell proteins play a more remarkable impact in the food supply chain of man and monogastric. For example, we are going out of the use of antibiotics in our feeds. So what you need to do is to replace them with probiotics that are basically single cell protein based. Secondly, in countries like Finland, they have gone beyond the level of just having single cell proteins. They do it as a matter of their major cuisines. As their cuisines, what I mean is that their sweets, their meats, their normal flavors in their food, and on and on and on and on and on. Now, why are we advocating for single cell protein as a replacement for other protein sources? One, we are having the multifaceted problems associated with production of normal protein sources like cattle, like poultry, and the others. One, space has been a contentious issue. That is the reason why today we have a lot of clashes, communal, regional, every level of clashes that's happening, and it has not helped the situation. But with single cell protein, we can actually take advantage of vertical space. We can use bioreactors to produce this in mass. Now, the other aspect, the other leg of it is that even the other protein sources, they can be better enriched when you apply the concept of either fermentation with the addition of single cell protein sources as probiotics in the production of these feed materials. This way, there is what we call real value addition. They appear to have similar structures, but they are financially and economically more dense and more important. Like health-wise, a lot of issues that we have as people are food or feed related, because of the fact that we consume a lot of things that have somehow negative effects on our lives and our health status. Basically because it gives for the proliferation of microbes that are harmful. So if you are feeding single cell protein, you are dominating the GIT with microbes that are capable, are beneficial, enriching, and having the capacity to convert bacteria into more richer forms. Let me give you an example. As good as soya bean will look like to you, it is still having some inhibiting effects. One, there is this Bowman-Bowick factor that does not allow for the release of potash, phosphorus. The release of phosphorus is difficult. So when you do every kind of process to liberate the phosphorus, either by grinding or heat treatment, the rest, you are also liable to destroying some nutrients. So, but when you subject soybean to the activity of single cell proteins, this is released, more enriched, and the humans and the users are better for it. So you can see that we can go on and on and on and on as to justifying why single cell protein is the way to go.